Good morning, all of you.
Good morning, ma'am.
Yes,
Morning,
good
ma'am.
morning.
Yes, ma'am.
Can we start the session? Okay. So let me share my screen.
Good morning, doctor.
Good morning, sir. So without any delay, I am starting the session. Huh?
I would like to introduce you.
Okay,
This
ma'am.
is a new semester, है ना? Fifth semester.
Okay, please.
Just 2 minutes. Uh, Hello, participants. 6 दिन की इस नेशनल वर्कशॉप में आप सभी का स्वागत है। राजकीय महाविद्यालय बदायूं और आईआईटी कानपुर के तत्वाधान में पीएसआईटी कानपुर के साझा संयोजन में ये वर्कशॉप 6 जनवरी से लगातार संचालित हो रही है। आज बीएससी के 5th सेमेस्टर के लिए ये वर्कशॉप वर्चुअल माध्यम से नोडल स्लाइड के एक्सपेरिमेंट को डिस्कस किया जाएगा। इसमें पीएसआईटी कानपुर के एसोसिएट प्रोफेसर डॉक्टर अपर्णा दीक्षित जी हमारे साथ कीनोट स्पीकर के रूप में आप लोगों को प्रैक्टिकल साझा करेंगी। मैं डॉक्टर अपर्णा दीक्षित जी से अनुरोध करूंगा कि वे देश भर के विभिन्न राज्यों के उपस्थित सभी प्रतिभागियों को वर्चुअल माध्यम से प्रयोग विधि समझाने की कृपा करें। डॉक्टर अपर्णा दीक्षित जी।
Thank you, sir, for your nice introduction. So without any delay, let's start the session. Can you see my screen?
Yes, ma'am.
Okay. So again, we need to go with this vlab.co.in and then we will click on physical sciences. As usual, whatever we have done, you can see here broad areas of virtual labs: electronics and communication, computer science and engineering, electrical engineering, mechanical, chemical, biotechnology, civil engineering, physical sciences, chemical sciences. So we have to go for physical sciences, right? You can see some labs which are based on physical sciences, advanced mechanics, basics of physics. Basics of physics actually prepared by IIT Kanpur, digital anthropology lab by IIT Guwahati, electricity and magnetism Amrita Vishwavidyalaya, heat and thermodynamics by Amrita Vishwavidyalaya, laser optics Amrita Vishwavidyalaya, mechanics virtual lab Amrita Vishwavidyalaya, optics virtual lab Amrita Vishwavidyalaya, virtual astrophysics IIT Kanpur, English and communication lab IIT Guwahati. Okay. So if we go with laser optics virtual lab, you can see some experiments. Michel's interferometer, refractive index of glass plate, index of liquid, Michel's interferometer with this wavelength of laser beam divergence and spot size, Newton's rings with angle determination, numerical aperture of optical fiber. So out of these, actually, this one are included in virtual lab curriculum. So now today we will perform Newton's ring. So you know the objective of Newton's ring. What is that? In Newton's ring, actually, the objective is to determine the wavelength of light source wavelength of sodium light source. Generally, we put sodium light source because the color of light is very soothing to eye. It never affects our retina. So normally we use
न्यू थिंग फॉर यू। ये आपको अमृता लैब की वेबसाइट के माध्यम से बहुत कुछ जानकारी मिलने वाली है कि आप एक्सपेरिमेंट को किस तरीके से कंडक्ट कराएंगे, वर्चुअली कैसे आप रीडिंग लेंगे, कैसे ग्राफ प्लॉट करेंगे। ये आपको जानना चाहिए और किस तरीके से इनपुट देकर आपको रीडिंग मेंटेन करके और फार्मूले में इंसर्ट करके किस तरीके से कनेक्शन करना है और एक्सपेरिमेंट को वर्चुअली कंडक्ट कराना है। मैडम आपको इनिशियली ये सारी चीज़ें सेटअप करके बता रही हैं और आपको एक एक्सपेरिमेंट सीख के बाकी एक्सपेरिमेंट अमृता लैब की वेबसाइट के माध्यम से कंडक्ट कराने चाहिए। वेट करें, थोड़ा नेटवर्क इशू है। मैडम विल रेस्पॉन्ड यू वेरी सून।
Good morning, sir.
जी मैडम, गुड मॉर्निंग। अभी
Good
मैडम का
morning.
नेटवर्क थोड़ा सा प्रॉब्लम कर रहा है।
अच्छा अच्छा
शी विल
ओके
ज्वाइन अगेन वेरी सून।
बल्कि हमारे यहाँ ऑप्टिक्स जो है 4th सेमेस्टर में है।
अच्छा अच्छा, तो नेशनल एजुकेशन पॉलिसी का यूनिवर्सिटी वाइज कंप्लायंस किया है। नेशनल एजुकेशन पॉलिसी यूनिफॉर्मली पूरे कंट्री में है, स्टेट में नहीं है। स्टेट में यूनिफॉर्म नहीं है।
या मैं वो ऐसे है कि किसी स्टेट में कोई पेपर है, मतलब पढ़ना तो वही सारे पेपर्स हैं, बट डिफरेंट डिफरेंट सेमेस्टर्स में ऐसा लगता है। आप लोग सेकंड सेमेस्टर में क्या पढ़ाते?
हम लोग सेकंड सेमेस्टर में तो ये थर्मोडायनेमिक्स है।
अच्छा।
और इसमें थर्मोडायनेमिक्स का पार्ट है और थोड़ा इलेक्ट्रिसिटी का पार्ट है। तो उसमें प्रैक्टिकल भी उसी पार्ट के हैं, लेकिन वो कन्वीनियंट नहीं है। सिलेबस के अकॉर्डिंग अगर होने चाहिए तो बच्चे को थोड़ा सा सहूलियत रहती है।
हाँ, हीट वाले कम एक्सपेरिमेंट्स मिलते हैं ना।
हाँ।
Can you see my screen?
Yes, ma'am.
Okay. I'm really very sorry because of bad network. I think experiencing some problem. So we were here, Newton's ring. Can you hear my voice?
Yes, madam. You
Yes,
are
ma'am.
audible.
Wait a minute, just give me.
It's very proper. Please continue.
So the aim is revise the concept of interference of light waves in general and thin film interference in particular, and to set up and observe Newton's rings, then to determine the wavelength of the given source. So let us see how to determine the wavelength of source of light by using Newton's ring assembly. Okay, so everybody knows about the thin film concept. Film, actually, why a film which has to be passed only light wave. So when we enter through the door, the dimension of door should be of the order of the human being. Okay. So what should be the dimension of the thin film? Thin film, the thickness of the film is always of the order of at least wavelength of the light source used. जिस light को enter करना है, at least उसके equal जरूर होना चाहिए. You know, nowadays we use anti-reflection coating on our aspects. Daily life में जो हम चश्मे पहनते हैं, पावर ग्लासेस, तो उनमें आपने देखा होगा आजकल जब आप ऑप्टिशियन के पास जाते हैं, सो बेसिकली दे यूज टू स्पीक अबाउट डू यू वांट एंटी रिफ्लेक्शन कोटिंग, डू यू वांट दिस कोटिंग फॉर द लैपटॉप, एंड all these coatings are thin film coating actually. With these coatings we generally avoid a reflection. रिफ्लेक्शन को हम क्या करते हैं, अवॉइड करते हैं. ओके, सो वंस यू हैव एंटी रिफ्लेक्शन कोटिंग ऑन योर एस्पेक्ट, so you drive the car or something like drive the bike, so you can see that आपके चश्मे पर कभी भी रिफ्लेक्शन लाइट का नहीं पड़ेगा because this is anti reflection coating. So now you can see here when the light beam this is the case of thin parallel film actually. कैसे interference होता है, that is matter here. So light beam incident at some angle of incidence I, and then you can see the medium 1 rarer, medium 2 denser, medium 3 again rarer. So when the light comes and fall on this the upper surface of the thin film whose thickness is d of the order of lambda wavelength, because light wave will enter through it, so at least it must be equal to the wavelength of light wave. So when it falls at an angle of incidence at the upper surface, So due to same medium, reflection occurs by following law of reflection, and due to change of medium from medium 1 to medium 2, it suffers refraction and goes towards here, and then again due to same medium another reflection will be occur, and then again you can see at this point due to change of medium light suffers a refraction and another reflected beam will be coming out. So these two reflected beam of light will interfere to each other because both are going in the same direction. When it has crest, so this beam has also crest. It has waves, so trough, so it will have trough. So basically both are in the same phase. Constant phase difference between them is maintained and their amplitude is nearly same. Why? Suppose inertially the amplitude was A. So this A is split into two equal half during reflection and refraction. So this is the method in parallel film through which actually we can divide the amplitude into two equal half. If their amplitude are same, so no issues, they will interfere to each other because our human eye will watch the interference pattern here. It seems like the beam of light is coming from here, this source. So these two reflected beam will work as a coherent sources, imaginary sources, which are derived from this original source. Okay, so both are having A by 2 will interfere to each other. As a result, you can see alternate arrangement of bright and dark fringes. हमें क्या मिलेगा? ब्राइट एंड डार्क फ्रिंज का अल्टरनेट अरेंजमेंट, एक एक करके, एक ब्राइट डार्क एंड सो ऑन. So this was the concept of thin parallel film. Now come to the Newton's ring, because Newton's ring is actually an application of wedge-shaped thin film. There are two types of thin film. Thin film can be either parallel or wedge-shaped. Okay, so this is the case of wedge-shaped thin film. If we cut any plano-convex surface from any spherical lens whose radius of curvature is large, so when we place this plano-convex lens on the surface of plain glass plate, a wedge-shaped thin film is formed on either side. Wedge-shape का मतलब है one surface is inclined, another is plane. So surface is inclined, which is curved also. Convex है ना ये. So this is curved also. So you can see there is an angle enclosed between curved surface and plane surface. So we can say this is the point of contact. So thickness of the film is 0 here. As we go far away from the point of contact, so here you can see the thickness of the film is increasing on, and it is maximum here. Okay. So this is nothing but a thickness of the film. This is nothing but thickness of the film. So you can see, just wait a minute, give me some time. So here you can see when the light incident normally on a upper surface of the film, so light is reflected from the upper surface, and again you can see second reflection occurs from the lower surface of the film and then transmitting out. So basically ray 1 and ray 2 both are having constant phase difference between them with a change in time, so they will interfere to each other. So as a result, you can see concentric circles of bright and dark rings. Concentric circles of bright and dark ring. Okay. So here, this is the concept of wedge-shaped thin film. And then we have this formula lambda is equal to dn plus p square minus dm square upon 4p r. dm is the diameter square of mth dark ring, and this is the diameter plus pth dark ring. P is the number of ring enclosed within some M or M plus Pth ring. And R is the radius of curvature from which actually this plano convex surface is being cut. Fine. So now we go to the procedure. This is the procedure of real lab, what we performed in our physical lab. Now you can see this is the procedure of simulator. So here you can see, click on the light on. So when you click on the light on button, so light will on. Then you need to choose the source of light, and then you can select the lens of desirable radius. You have to decide the radius of the spherical lens, then adjust the microscope position to view clearly Newton's ring. और इसके बाद क्या करेंगे, we will focus the microscope to view the rings very clearly, and then we will keep fix the cross wire from center to the 20th ring. 20th ring, because after 20th ring we observe, as we move further the micrometer, so there will be overlapping between the number of rings, so we cannot identify the number of ring whether it is 21st or 22nd, because our human eye is very sensitive. Okay, so this could not be observed properly, so we generally stop the process at 20th ring. Okay, then you have to take the readings of ring on either side of the central dark, like left side and a right side, as like this. Now we can enter the reading in this tabular form and calculate the wavelength of light by using the given formula. You can see there is a one main scale division. So this is 1 by 20, because total 20 divisions are there, and suppose we have a 3 and 4, in between 3 and 4 we have 20 division, so 4 minus 3 upon 20 is the value of one division in main scale. And you can see some number like 50 divisions are drawn on the vernier scale. So what is the least count? 1 upon 20 by 50, that is 1 upon 1000.001. कितना हो जाएगा? 0.001. Okay, so this is the least count. Now we can go ahead for the self evaluation form. We can fill it properly and then submit it. Kindly solve it very properly, so that it may be realized like whether your theory concept good or not. Now we come to simulator. In simulator you can see the arrangement of Newton's ring assembly. So here again, if you follow the air film, follow air film and choose the light source. Suppose this is neon. Okay, so here you can basically make more light. Okay, earlier it was not so bright, but when we move over here, so we can see more clarity is can be seen in the rings. So these rings are very intense. Can you see very clearly the number of rings? Central spot is dark. This is reflected light case. Light is coming on one side. Okay, this is a plano convex lens. Light is coming here and will fall on 45-degree inclined glass plate here. Okay, and then what will happen? The light will incident basically normally. Okay, कैसे इंसिडेंट होगी? नॉर्मली. So when the incidence is normal, so reflection takes place through the upper surface of the film and lower surface of the film, and interference takes place. As a result, you can see the alternate arrangement of concentric circles. This is the case of reflected light because light is coming from, suppose, here, and then you can see here. So this is the case of reflected. Okay. So all are in the same vertical plane. Now you can see here, you can see the main scale and vernier scale. So in vernier scale, you can see total 50 divisions, and here you can see the value of one division is 1 by 20, and what is the least count 0.00. Now we can go with the variables. We can adjust the radius of lens. Normally it should be 100, whatever use in our lab. 100 to 50 to 100 maximum. So generally लैब में जो होते हैं वो 100 सेंटीमीटर 100 से ऊपर ही होते हैं 100 सेंटीमीटर से लेकर 1 मैक्सिमम अदरवाइज नॉर्मली 100 सेंटीमीटर तो हो गई लेट्स चूज some 65 centimeter rather than taking 50 centimeter and then microscope position. Okay, you can see here the wire crossed with each other. One wire is here along y-axis and one wire is x-axis. So these two wires are crossing with each other. So these are actually cross wires. ये क्या हो गया जो हो गया. Fine. Now you can see one more thing. Wait a minute. Now microscope focus 4.5 centimeter. You can choose that. Show the what is that out 6100. Okay, so you can see actually wait a minute. So here you can see the wavelength is coming out 6100 angstrom. But what is the standard value? 5893 angstrom. ठीक है तो ये क्या है उससे ज्यादा आ रहा है दैट मीन्स देयर इज अ डिफरेंस बिटवीन द वेवलेंथ सो यू कैन कैलकुलेट द परसेंटेज error. But anyways, earlier there was a table, but now actually table is not available here. Copy notebook and then try to maintain it. Okay, so this is it is at only center cross at the boundaries of dark ring. Okay, so we can do it. This is the first arc, this is the second arc. Okay, so we can put it here and then to find out the wavelength of light source. So we can move this crosswire towards left as well as toward right. So suppose we can move the crosswire with the help of these two arrows. You can see this. Keep it here and try to find out the value, main scale reading and vernier scale reading. So what is mentioned on the main scale? This is 3, 2.9, 2.8, 2.7, 2.5, 2.4 and this is 2.3. That is 3 to completely chala gaya. So let's write 2.3 main scale reading. And for what about the vernier scale? You can see here which division is clearly coinciding with the main scale. Can you please tell me? कौन सा डिवीजन मैच कर रहा है? बेटा कैन यू प्लीज टेल मी कौन सा मैच कर रहा है? 0 1 2 3 4 5 10 11 12 दैट इज 20 30 40 50. बताइए कौन सा कौन सेट कर रहा है एग्जैक्टली? कैन एनीवन टेल मी रीजन इनमें से कौन से हैं जो बिल्कुल एग्जैक्टली यहाँ पे मैच कर रहे हैं? क्या बात है? No one is answering?
Actually, it is first or second only.
No, it's not first and second. You can see there are various divisions: first, second, third, also fourth, also
You
fifth.
can
Also,
just enlarge it and see, है ना?
I have already enlarged.
I am enlarging on
It's
my.
not clear enough.
Actually, you cannot do that. I have already zoomed it.
It's not clear enough. I think the quality isn't that good to determine which one is coinciding.
Now you can see. Let's third. Okay, third division. 3 into 0.001 is the main vernier scale reading. And here you can see 2.3 already passed away and approaching to 2.4. 2.4 is there. 2.3 plus 3 into 0.001. That is
Ma'am, in
2.
that, excuse me.
Madam, yes, what's happened, madam?
In that case, you have to take 2.35.
No, we cannot because we have chosen that in the least count, so no issues. So this
But
is 2.3 3 into 0.001, that is 0.003. So this is the main vernier scale is giving out 2.303. So this is the reading of when you put the crosswire at the boundary of second dark. So you may basically maintain the we can say observation table at first, and then you can change the number of rings. And number of rings you can choose like n equal to 2, then 4, then 6, then 8 in even order. And you can find out one more thing. There will be little change only in the main scale reading because just you when you move from zeroth order to second order dark or then fourth order, there will be little move only in the main scale, but vernier scale can have a movement of many divisions, right? So basically now if we go with the next boundary and then you can see the result. So please try to maintain everything in your notebook also in a parallel way, because as before Vandita ma'am and some other participants have already suggested that they should keep the values in the formula, theoretical formula on their own and try to find out the value and then compare the result of virtual lab. Okay, so we have chosen, so for r is equal to 65 centimeter, this is the radius of curvature, and number of ring is n equal to 2, and here what is the uh, main scale plus vernier scale reading, that is you can see this is 2.303. Okay, now first of all we will move our crosswire towards left only. Okay, towards left only. So here You can just wait a minute. Let me minimize it slightly. Okay. Now you can move this. Is a third boundary. This is fourth boundary. Okay. Now when you move on fourth boundary, just see the result of main scale 2.5. This is 2.4, 2.3. Exactly 2.3 has been passed away, as I have already said. That is if first few readings at like 3 to 4, the main scale will never affect. Only the change can be measured in vernier scale. Now you have to go for the vernier scale division. So which one is matching? Can you please tell me? Can anyone please tell me?
I think 2.6, ma'am.
Which one is here? Division. I am saying that which division is coinciding here? बच्चों यू कैन सी 0 से 10 के बीच में कोई भी मैच नहीं कर रहा. 10 से 20 के बीच में कैन यू सी? आई थिंक 10 से 20 के बीच में मैच कर रहे हैं.
13 और 14 में भी.
मे बी इट इज 11, 12, 13, 14, 13, 14, but if I see with my screen, so it is not so. This is 15, 16, 17, 18 is clearly visible. 18. Fine. So
Yes, ma'am.
this 18, 18 into 0.001 gives 0.018. And 2.3 is the main scale reading. So finally it is 2.318. Okay. Now again, go for next. Like this was the first boundary, second, third, fourth, fifth, now sixth. Okay, n equal to 6. Now at this moment you can see the readings first. 2.3. 2.3 is now going beyond 0. So how many divisions has been passed away in the main scale? 2.5, 2.4, 2.3. Actually 2.2, because 2.3 is not exactly uh, at 0. So basically we can choose 2.2. Okay. Now go with the vernier scale division. So which division
Excuse
is
me, ma'am.
clearly?
हेलो.
Yes, madam, बोलिए.
ये जो है मेन स्केल में एक डिवीजन 2.05 का है, सो इट इज 2.25.
That's it. We have already discussed about the least count, ma'am.
या लीस्ट काउंट की बात नहीं कर रही हूँ. मेन स्केल का एक डिवीजन मेन स्केल की रीडिंग के लिए है ना, तो इट इज 2.25. इट इज द जीरो इज बिटवीन 2.25 एंड 2.3.
Can you see the number of divisions on the vernier scale? And let me know the which number of divisions actually coinciding at 0. Sorry, with the main scale. No one else? Bachcho, please respond. I have little less time.
Ma'am, I can see 10 divisions in one scale.
10 division. No, not at all. 10 is not coinciding. What is that? Please see once again. Number of divisions should be appropriate, otherwise your readings will be little wrong and the wavelength will be affected. Okay, this always matters. Please check it again and tell me the answer. If you go from first set 0 से 10, कोई मैच कर रहा है? नहीं. 10 से 20? No. 20 से 30? No. 20 से 40?
40. 40 looks like it's matching.
Exactly 40. So that is 40 into 0.001, that is 0.0. You can calculate it and write the value of main scale plus vernier scale into least count. Okay. So what is the value coming out finally? Ma'am, can you please tell me? Ma'am, are you there? Am I audible or not?
Yes, ma'am, you are audible, but I think your screen is.
No one is responding, like sometimes basically you people get stopped. Please respond here so that we can go ahead, right? Okay.
I think your screen is stuck, ma'am.
Sorry, your voice is not audible properly. Can you please speak again? नहीं, वेट मिनट. आप स्क्रीन देख सकते हैं यहाँ पर?
Yes, madam. Yes. Yes,
Maybe
ma'am.
I think as far as a bad network है, that's why the thing could not be arranged very
No, ma'am.
properly.
Screen is properly visible, ma'am.
Okay, fine. So sometimes वो रुक भी जाता है शायद, मे बी. ठीक है, स्टिक हो जाएगा क्योंकि आज बैंडविड्थ थोड़ा लो है. Okay, so we can see 40 here, right? Now you can note down the reading left hand side again, and then you can go for the n equal to 8. So again you can move this, you can put your cursor here. So I think this was the center, first, second, third, fourth, fifth, sixth, seventh, eighth. So one little bit, this is the boundary of 8, and then you can go with the 10, 12, 14. So basically you can move it towards left, and now you have to move the cursor of this meter. Just put your cursor here on this screw. You can see hand here ना, hand आपको दिखाई दे रहा होगा.
Yes, ma'am.
So this is actually center. No, this is the center actually. Now we were moving on right hand side. So this is the boundary of first dark, second dark. So suppose we are doing on the second dark, then you can see the result here. Now you can see this is 4, 2.5. sorry 3.5, 3, and 2.9, 2.8, 2.7, 2.6, 2.5. 2.5 completely gone away. So according to madam, we can choose 0.05 for the this the point. What is it? 2.5 to 2.55, and then you can go with the divisions, number of divisions, which is coinciding very well on the main scale. So let's see 0 to 10 कौन सा मैच कर रहा है और 10 to 20 कौन मैच कर रहा है और from 0 to 50 तक कौन सा मैच कर रहा है. So you can see the
2.95 looks like.
मैम प्रॉपरली कैसे देखेंगे कि एन कैसे ले रहे हैं डार्क या ब्राइट के लिए?
बेटा देखो देयर इज नो बाउंड्री ऑफ ब्राइट. ब्राइट को कौन करता है सेपरेट आउट करता है डार्क. ओके सो दिस इज डार्क ना, ये डार्क है पैच. इसका ये बाउंड्री हो गया. ये तो सेंट्रल स्पॉट है. सेंट्रल स्पॉट क्या होता है रिफ्लेक्टेड में? दिस सीम्स टू बी डार्क. ऐसा क्यों है? बिकॉज जब पार्ट डिफरेंस इन केस ऑफ रिफ्लेक्टेड लाइट is 2 mu plus lambda by 2, and T is the thickness of the film. T or you can say D, जो यहाँ पे D लिखा है. Let's say T, 2 mu T plus lambda by 2. तो center that is point of contact. Point of contact में thickness क्या होगी? 0 होगी T. तो 2 mu T plus lambda by 2 कितना बचा? If T is 0, तो 2 mu T plus lambda by 2 is lambda by 2. What is the coefficient of lambda by 2? Lambda by 2 का coefficient क्या है?
1.
1. Is it odd number or even?
Odd.
So odd multiple of lambda by 2 for part difference. Is it condition for maximum intensity or minimum intensity?
Minimum.
मैक्सिमम इंटेंसिटी. इवन की मिनिमम. ये ऑड है ना, तो मिनिमम इंटेंसिटी
Minimum.
कौन सी होगी? मिनिमम. सो व्हाट टाइप ऑफ इंटरफेरेंस टेक्स प्लेस? डिस्ट्रक्टिव. दैट मीन्स कि रिंग सीम्स टू बी डार्क और ब्राइट इफ द इंटेंसिटी इज मिनिमम.
Dark.
So center always appears to be dark in case of reflected light. But in transmitted light, then you can see the part difference is 2 mu T plus lambda by 2 plus lambda by 2. That is no change in path and phase according to Stokes treatment. तो इसका मतलब क्या हुआ? 2 mu T is only. So when you put T equal to 0, so what is the part difference coming out? Only 0. ठीक है? Which is the even multiple of lambda by 2, like 0, 2, 4, 6, 8 and all. Fine. So even multiple of lambda by 2 is the condition of maximum intensity or minimum intensity?
Maximum.
Maximum. So rings appears to be bright or dark?
Bright.
But generally we do not perform this case of transmitted light because we will have only fainter spot of bright and dark rings. Okay, तो इसलिए transmitted light हम lab में नहीं करते हैं. We generally perform only कौन सा perform करते हैं? Only reflected light. Okay, now you can repeat the experiment. Suppose you have put here first boundary and second boundary. This is third and this is the boundary of fourth. Okay, so you can put it with the help of this cursor. This is the boundary of fourth, and then you can find out the result here. How many divisions have been passed away on 0 on main scale? This is 2.5. 2.5 clearly gone away, and this is 2. Actually 2.6 नहीं है, little bit आगे जा रहा है. So let's put only 2.55. And here on main scale, vernier scale, you have to see the divisions. Actually you can see 10 तक नहीं कर रहा है, 20 तक नहीं कर रहा है, 30 नहीं कर रहा है, then 40 you can say 40 is basically coinciding exactly. Okay, so 40 into least count plus main scale, this is the reading of B, not A, B, because you are moving now the crosswire on the right hand side with the help of your cursor. Okay, so these two are the points through which actually you can make adjustment. With this actually you can focus more and more light, and here you can shift the crossfire towards left as well as toward the right. So here you can see the result and then try to find out the value. Okay, so here you have a full chance to, okay, I have chosen neon. Neon के लिए ठीक है 6100, but sodium के लिए कितना 5893. So basically when you choose a sodium source of light and then you can go with the light on. So you can see the light here and move the cursor in this way. As already we know the wavelength of sodium light source is 5893, whereas in dual spectral line 5890 angstrom, 5896 angstrom. When you take average 5893, you make more focus. So you can see the blur image of the rings, make it sharp. Now it has been अब sharp दिख रही हैं, I think so, है ना?
Yes, ma'am.
Now you can choose the values here. You can choose some centimeter and the microscope position, microscope focus, and then you can go with the result. 5890 angstrom. So what is the value coming out? 5890 angstrom. So, but don't rely on this value. Just calculate this. When you go with the theory, in procedure, you can see the observation table here. Number of rings you can write here n equal to 2, n equal to 4, up to the n equal to 20. Fine. This is left hand side A, right hand side B. Then take a difference between them. Difference, which one is large, you can take the difference between them. And then you have to take the squares of diameter, and then you can choose, this is a mth dark ring, the next one is m plus pth. So consecutively you can have the difference between them, like d2 for n equal to 2, d2, and d2 square for n equal to 4, this is d4, d4 square. So initially you will take a difference between d4 square minus d square, then d6 square minus d4 square. So you will have total 9 options, because from 2 to 10, 2 to 20, I think total to 11 readings will be taken. And then when you take mutual difference between them, so you have total 9 to 10 observations. Take average value of this you have for n equal to 2 transfer. No, for n plus p minus p, like d4 square minus d2 square, d6 square minus d4 square, d8 square minus d6 square, d20 square minus d18 square. So you have to take the average of these two, take sum of these and divide it by the number of readings, and then have this value. Put it here. Lambda is equal to this one, 4. What is p value? P actually, if you have chosen n equal to p, so what is n plus p? Equal to 4. So how many rings gone away between second and fourth? कितने चले गए? 2 चले गए. Just forget about the central spot, cannot be countable.
Okay. How do we choose P?
How do we choose P? Okay. So beta, when we take orders of ring here, n equal to 2, then n equal to 4, then n equal to 6, and then this. So this is nothing but m equal to, and next one is m plus p, which is equal to 4. So m plus p equal to 4 and m equal to 2. So what is the value of p? By simplifying these two equation, कितना मिला हमें? p का value 2 मिला है ना? So this 2 will be maintained because you are repeating the experiment with the same interval of rings. Okay, same number
So
of
P
rings
will be constant throughout the
will
readings.
be constant. Alright. Throughout the observation, only dm plus p square minus dm square is the variable here upon 4p. Our radius of curvature we have already chosen. So please put the same value. And then you can write here in nanometer, or you may convert it into angstrom also. So
Ma'am,
this is
मैम
here we taken the reading of left side and right side, and from this
yes.
we can determining the diameter. But when we are calculating the diameter, that time we are subtracting the reading from left side to the right side. So
Yes.
diameter is actually the addition. So why we
Actually,
subtracting them?
no, that is not okay, because we have a central spot also, but that cannot, that is considered as a zeroth order. So basically, we need to take a difference between A and B. Okay.
Okay, ma'am. Thank you.
So here, once you have the readings, you can plot a graph also. And this is a very must exercise for the science student or engineering students. They must plot a graph also, do graphical analysis. So when you plot a graph between order of ring and dm plus p dn square, so you can see the graph will be uniform. Okay, on increasing, basically the number of rings, diameter square will be increasing on. Okay, so you can see a straight line graph should be represented there. And then when you see the straight line, you may draw perpendicular towards x-axis as well as on the y-axis at any two endpoints. So suppose we have this graph, so and we are getting this straight line. So make a normal here and make a normal here. So y-axis is representing d square. So this is for n plus pth. So d square. So y2 minus y1 is what? dm plus p square minus dm square. And m plus p is x2 and m is x1. So m plus p minus m gives out x2 minus x1 gives out p. So y2 minus y1 upon x2 minus x1 is nothing but a slope. So slope is coming out dm plus p square minus dm square p. So here you can write this dm plus p square minus dm square upon p as slope. So this formula will become slope upon 4r. So now it would become a graphical formula. Then you can the value and try to find out the value of wavelength of light source used with the help of graphical analysis. Then you will have two values of wavelength, one from the theoretical formula and from the graphical formula, and you can compare them values and try to find out the percentage error, right? So this is must exercise, must do that. If
मैम
student do not, they cannot realize the effect of interference pattern in case of misring. Okay, you may ask better, please.
मैम जैसे ये m प्लस p है और m है, इन दोनों के बीच डिफरेंस हम फाइंड कर रहे हैं, तो एटलीस्ट ये कह सकते हैं कि दो फ्रिंजेस के बीच में हम डायमीटर फाइंड कर रहे हैं,
rings
डायमीटर फाइंड कर रहे हैं, तो डायमीटर से हमें वेवलेंथ फाइंड हो रही है. और मैम माइक्रोस्कोप रीडिंग जो है इसमें लेफ्ट और राइट जो सेम रिंग के लिए अलग अलग वैल्यू आएंगे।
So you can see plot of n versus dm plus p square minus dm square. ठीक है, ये प्रैक्टिस करना और मुझे बताना. So now the session is over at my end. Now you can ask questions. Please go with the questions so that we can discuss it. And I have a class also, so please try to ask question. Ali, you have some okay trouble. This is
मैम
resolved.
वेरी यूज ऑफ न्यूटन्स रिंग डार्क एंड ब्राइट
डेस्कटॉप पे ही है इसमें।
मैम एक्चुअली
Use of that.
रियल
What do you want to say? I don't understand. What do you want to say?
ये दिल्ली को आरसी भी जाएगा।
मैम ये डार्क और जैसे ब्राइट आ रहा है तो इनका यूज क्या है रियल लाइफ में, जैसे न्यूटन्स रिंग का?
There are so many things. There are a lot of applications of Newton's ring. Like if we go for the thin film testing, अगर हम thin film testing के लिए जाते हैं, so basically thin film जब भी आपकी use होती हैं, so these film may be used as a substrate in case of semiconductors. Okay, जब भी हम कोई सामान खरीदते हैं ना, तो उसका वैल्यू पहले से यूज कर grating surface of the grating, it has been written 15,000 lines. तो LPI लिखा रहता है उसमें 15,000 LPI. ओके, मतलब ये इसका मतलब ये है कि when it configured it was counted well and then it was written over there, है ना? तो इसी तरीके से ये एप्लीकेशन कैसे इंडस्ट्रियल यूज में भी हो सकता है, मे बी the medical also. There is a vast use of these experimental applications. इन सब के vast use होते हैं. अगर हम न्यूटन्स रिंग की बात करें तो न्यूटन्स रिंग में जनरली थिन फिल्म का सबसे बड़ा रोल है. तो थिन फिल्म जो है, एक्चुअली थिन फिल्म के बहुत सारे एप्लीकेशन nowadays we are using vastly this thin film. Okay, अभी आपने पढ़ा होगा सेमीकंडक्टर्स में सिलिकॉन बहुत यूज होता है. सिलिकॉन काफी कुछ खत्म हो चुका है. So people are looking over the graphene sheet. And graphene sheets are actually occurred in Sweden only. So Sweden is the only country where you can see more graphene. ठीक है, actually Sweden is rich in graphene. So basically, when you have these sheets, then you can go for the transparent sheets. So basically, can be applied in different applications or different experimental applications. You can whether use as a semiconductor, you can use them as a perovskite material, non-perovskite material, double perovskite, Hosler or non-Hosler type of material. Okay, so many applications there. So optoelectronics. So basically, you put these thin film as a substrate on a semiconductors. So once you have the property of the thin film, the property of the thin film when light comes through it, so what will be the wavelength of light source if it has been observed in that particular basically thin film. You must have a information of thickness of the film. So you put it into formula and find out the thickness of the film. So you will verify it experimentally whether or theoretically the values, and then you can write the standard value. So many times you perform the experiment in the testified labs, and then you can put the value on their brochure. Okay. So basically, these are the application you can go. Even I think it must be written over there. The application not given, but these are some few applications nowadays the people are using in case of material testing. Okay.
मैम ऑप्टिकल फाइबर केबल जो होता है उसमें इसका यूज कहीं है?
ऑप्टिकल फाइबर केबल.
यस मैम.
ऑप्टिकल फाइबर किस लिए यूज करते हैं? ऑप्टिकल फाइबर किस लिए यूज करते हैं?
ऑप्टिकल फाइबर टोटल इंटरनल रिफ्लेक्शन करता है, ये डाटा को ट्रांसमिट करने के लिए होता है।
डेटा को ट्रांसमिट करने के लिए। ओके,
यस मैम।
सो जस्ट बाय फॉलोइंग विच प्रिंसिपल?
टोटल
रिफ्लेक्शन।
टोटल इंटरनल रिफ्लेक्शन, राइट। शीट कैसी होनी चाहिए सो दैट लाइट कैन गो वन एंड टू अनदर एंड? ट्रांसपेरेंट होनी चाहिए। ओके, तो क्या हम लेते हैं वहां पर? ग्लास लेते हैं नॉर्मल, है ना। ऑप्टिकल फाइबर में हम क्या लेते हैं? ग्लास का सेंटर जो कोर होता है इज मेड अप ऑफ ग्लास। फाइन। तो बेसिकली सी देयर, यहाँ पे जो पैरेलल फिल्म यू कैन टेक इवन ग्लास, इवन ऑयल, वाटर, सोपी फिल्म। हम घर में साफ करते हैं ना डेली, you can see the soap bubbles. The soap bubble is nothing but a type of film, है ना? When the sunlight comes through it, so you see some beautiful colors. When you rotate your retina, अपना retina जब rotate करते हो, so incidence basically changes, and the beautiful colors can be seen in our view. तो ये सारी चीजें क्या है कि actually when you go for the bicycle ride and go for the fuel station, petrol fill karate hain, so oil drop basically spreads over the surface of ground. तो जो surface of ground है, when the light comes through it, तो you can see some colors. तो ऐसे चीजें हमें जो है डेली लाइफ में ये दिखती भी हैं, ऐसा नहीं कि एक्सपेरिमेंट में ही हो रही हैं। फाइन। तो यहाँ पे मतलब एक्सपेरिमेंट का एक्चुअली क्या है कि यू कैन सी देयर आर लॉट ऑफ एप्लीकेशंस, देयर यूजेस, एंड the people are basically doing research still in Newton's ring also. There are so many methods, so they have changed the experiment also a little bit, but this is the we can say the parent experiment, so through which actually we can find wavelength of source of light in very appropriate manner. Okay. Anyone else?
मैम यहाँ पे जैसे सोडियम और नियॉन लाइट है, तो ये क्या है मैम? सोडियम और नियॉन मतलब जैसे अगर सोर्स देखें तो ये कैसे प्रोड्यूस हो रही हैं?
बेटा सोडियम जो आपको पता होगा, आपके बचपन में पता नहीं था कि नहीं था। नाउ दिस द स्ट्रीट लाइट हैज बीन रिप्लेस्ड फ्रॉम सोडियम टू मरकरी। आजकल हमें मरकरी मिलने लगे, ठीक है। पहले हमारे बचपन में ये सोडियम लाइट लगी होती थी। सोडियम लाइट आंखों के लिए सबसे ज्यादा फायदेमंद होती है। इससे जो डार्क एक वो जो ब्राइटनेस है लाइट की, वो बहुत ज्यादा इफेक्टिवली रेटिना को जो है बहुत अफेक्ट नहीं करती है। इट्स वेरी सूदिंग टू आई। तो आपकी जो लैब है उसमें हम कौन सा कलर यूज करते हैं? सोडियम लाइट, ऑलमोस्ट येलो लाइट, ठीक है। तो हम वो यूज करते हैं। बट दिस इज द ब्यूटी ऑफ वर्चुअल लैब, यहाँ पर हम डिफरेंट सोर्स ऑफ लाइट भी यूज कर सकते हैं, राइट। जैसे कि नियॉन, और इन्होंने और कौन से ऑप्शंस दिए हैं? ग्रीन लाइट, रेड लाइट, है ना। सो नियॉन का अगर हम वेवलेंथ देखें तो 6100 होता है, ठीक है। सो बेसिकली they are involving more source. You can have idea. Even you can see the effect of diameter of ring in case of green light and red light. क्यों? क्योंकि यहाँ पे एक बड़े साफ तौर पे देखो कि लैम्डा डी एन स्क्वायर इज डायरेक्टली प्रोपोर्शनल टू द आर एन इज डायरेक्टली प्रोपोर्शनल टू द स्क्वायर रूट ऑफ लैम्डा ना, ठीक है। सो व्हेन लैम्डा इंक्रीजेस, so diameter also increases. Is it so or not? So in the visible region, which color wavelength is large? Violet or red? किसका वेवलेंथ ज्यादा है?
मोर देन ग्रेड वायलेट।
वायलेट का सबसे कम।
अच्छा हाँ मैम,
है ना। विब ग्योर से ध्यान रखो, विब ग्योर से ध्यान रखो, है ना। V लेस देन, I लेस देन, ऐसे करके याद रखो। तो R का सबसे ज्यादा है लैम्डा, ठीक है। सो रेडियस भी उसका ज्यादा होगा. तो even you may apply the different source of light here and try to find out the effect of diameter on the wavelength of light. Wavelength of light का effect इसमें this is the pattern of ring. Okay, now just choose a in place of sodium red. So little bit you need to uh, need more focus here. Okay. You can see little bit the diameter of the rings will be large. Even you can see in the result also कि diameter उसका थोड़ा सा ज़्यादा ही आएगा. Fine. So this is effect of the wavelength of light source used in case of the diameter. Okay. Even as the refractive index. So refractive index का तो हम लोग शायद कल perform करेंगे, not today. Okay. So anyone else?
बल्ब में कौन सा जैसे सोर्स होगा हमारा?
बल्ब में बताया ना अभी, जैसे सोडियम लिया है, सोडियम की जगह हम रेड लाइट भी ले सकते हैं, ग्रीन भी ले सकते हैं, नियॉन बल्ब भी ले सकते हैं, है ना. जब हम बल्ब खरीदने जाते हैं किट में, इलेक्ट्रिशियन जो शॉप्स होती हैं इलेक्ट्रिक, बेटा वैसे भी मैं बता दूं सोडियम लाइट सोर्स ही हमारी लैब में यूज होता है. जनरली रेड लाइट एंड ग्रीन लाइट आर नॉट बीइंग यूज्ड एज अ सोर्स ऑफ लाइट. ठीक है, तो वो हार्मफुल है नहीं. बट सपोज आपके लिए अगर आपको पर्सनली, then you can go for the checkup also. You can wash your eyes many times. ठीक है.
Okay, ma'am.
हाँ, that's it only. This is only. बिकॉज आपको लैब में हमेशा वही काम करने को दिया जाएगा जो परमिसिबल है ना. एनीवन एल्स?
Ma'am, can raise your hands?
Tomorrow we will continue this same not same experiment but Newton's ring also. If you have any question you may ask tomorrow also, or as well as on the WhatsApp group. Please ask the questions. आज थोड़ा सा नेटवर्क का भी इशू रहा है, so if you wish to repeat the experiment I can repeat also, don't worry.
No issue, madam. Workshop conducted very properly. Thank you.
Suppose अगर कोई बच्चा अगर पूछना भी चाहता है, so we can do one more thing like a little bit अगर theory में भी discuss करना है so we can discuss more. Fine?
हाँ, बाद में व्हाट्सएप ग्रुप के थ्रू भी कर सकते हैं
जी.
यूट्यूब चैनल पे भी बच्चे क्वेरी करते हैं, उनको भी रिस्क किया जा रहा है. थैंक यू मैडम. ये वर्कशॉप का 5वां दिन है और हमने नेशनल लेवल के कई स्टेट के स्टूडेंट्स के लिए ये वर्कशॉप ऑर्गेनाइज करके रखी हुई है और मैडम की सपोर्ट से हम इस वर्कशॉप को कंडक्ट करा पा रहे हैं. तो आज मैडम ने जो न्यूटन्स रिंग का एक्सपेरिमेंट डिस्कस किया बहुत अच्छा लगा. मैडम ने बताया अदर साइड फ्रॉम राइट साइड यू हैव टू प्लेस द कर्सर फ्रॉम इनर ऑन द इनर साइड ऑफ दैट पर्टिकुलर रिंग. That's why you will remove the thickness of the particular ring. है ना? You will get the perfect diameter of that particular ring. तो बहुत अच्छी बात है. वर्चुअली आप लोग इस बात के लिए इस वर्कशॉप से इंटरेस्ट ले रहे हैं कि वर्चुअली आपको एक्सपेरिमेंट सीखने को मिल रहे हैं. प्रोफेसर वंदिता मैडम हमारे साथ लगातार बनी हुई हैं. बहुत इनोवेटिव वर्क हो रहा है. मैडम भी इंटरेस्ट ले रही हैं. मैं मैडम से रिक्वेस्ट करूंगा कि 2 शब्द हमारे स्टूडेंट्स के लिए जरूर बोलें. प्रोफेसर वंदिता मैडम फ्रॉम KL DAV कॉलेज रुड़की. मैडम प्लीज.
हेलो
Yes,
Good
you are
afternoon to
audible.
all. I am also very amused कि बच्चे भी इंटरेस्ट ले रहे हैं, ये बड़ी अच्छी बात है. They are learning and जो है आप खुद करके देखें तब आपको ज़्यादा समझ में आएगा. Maybe have you opened your account there in virtual lab, Amrita University, or not? Has anyone did that?
Students, please respond.
आपने अपना अकाउंट खोला उसमें वर्चुअल लैब में गए आप अपने आप से?
स्टूडेंट्स ने
Yes.
अमृता लैब की वेबसाइट ओपन की है, बताएं.
Most of
हाँ
the
मैम.
students have opened their ID password there on the virtual lab because some of the students were approaching me on the WhatsApp personally. So I did inform them like, please go ahead and do this. Even I think few students have given me the result also
Oh,
personally.
great, great. So you are getting output
Even
from the
in
students.
the evening also,
That
evening
is
hours,
the
the
result of this workshop. It is very good. Doing. सबसे अच्छा तो यही है कि आप रीडिंग लीजिए, कैलकुलेशन करिए एंड देन ओनली. यहाँ पे ये देख रही थी मैं, कोर्स इज नॉट सीन हियर. आई डोंट नो, जस्ट on the virtual lab, the source cannot be seen. Aparna ma'am?
एक्चुअली
लाइट को कवर नहीं कर पाते हैं.
हाँ वही
पिक्चर
तो देख रही हूँ, वो बच्चों
पिक्चर में
को
नहीं कवर
फीलिंग
कर
नहीं आ
पाते.
पाती इसकी
हाँ,
कि शायद कि कैसे
वो
आ रहा
चीज
है
नहीं
वहां
आ
पे.
पाती.
दैट इज द
एक्चुअली
ड्रॉबैक ऑफ
असेंबली
द
हम
वर्चुअल लैब. दैट इज द ड्रॉबैक ऑफ द वर्चुअल.
Yeah,
but we will try to remove this discrepancy in virtual reality
yeah.
because we
आप
can
दिखा रहे
show,
हैं कुछ हमें ना?
we can show the configuration like we have chosen this source of light by hand by
Okay,
experiencing virtual reality, choosing
okay.
different source of light. Then we can keep the source of light at the focus of the convex lens. Then the beam will become plane and parallel, and then will fall on the 45-degree inclined glass plate, right? And
Yeah,
so
yeah.
that the incidence become normal and will focused on the plano-convex surface. Then reflection takes place from the upper
Actually,
surface.
here they will not be able. They are not able to see the lens where it has kept.
It is not possible just because of otherwise the scale will not be visible.
Yeah. I
Yeah,
understand
if
this.
there is a 360-degree view, then they can see.
Yeah.
So it is quite possible only in case of VR technology.
Yeah. So I'm looking forward to tomorrow's session.
Yes,
यस
ma'am.
प्लीज, यस प्लीज.
That is together by tomorrow.
तो
Okay.
And
पार्टिसिपेंट्स,
Now
this,
you have class.
आप सभी स्टूडेंट्स कल हमारी वर्कशॉप में टाइम से पार्टिसिपेट करेंगे. गूगल लिंक वही रहता है, तो आपको कोई ऐसी प्रॉब्लम नहीं आनी चाहिए. वैसे व्हाट्सएप ग्रुप पर सर्कुलेट भी किया जाता है और यूट्यूब चैनल को भी आप लोग बार-बार यूट्यूब चैनल पर लाइव ये वर्कशॉप प्रसारित की गई है, तो आप उसको भी एंटरटेन कर सकते हैं, बार-बार उसको सुन सकते हैं. जिन्होंने अभी कुछ छूटा हुआ है वे भी एंटरटेन कर सकते हैं. अपने नोट्स बनाए होंगे और असाइनमेंट के तौर पर आप इसको कल एक्सपेरिमेंट करेंगे और मैडम से डिस्कस करेंगे अगर कुछ
बेटा सभी को ग्राफ प्लॉट करना है, मैन्युअली फॉर्मूले में रख करके वैल्यू निकालनी है and check whether it is matching to the virtual lab value or not. Please go through it and let me know the answer.
Next.
And share your calculation as well.
Yes.
Calculation is the main thing.
That will make actually more successful the
क्योंकि
workshop.
वहाँ पे यूनिट्स की डिफरेंस आ जाती है, कभी फिर गड़बड़ होती है फिर काफी.
Ultimately result होना चाहिए.
Thanks a lot. Congratulations. And thank you Aparna ji.
Thank you madam.
For devoting such a hard time here.
तो फीडबैक लिंक हम लोग व्हाट्सएप ग्रुप के थ्रू सर्कुलेट करेंगे. अभी आप लोग फीडबैक को एंटरटेन करें, फीडबैक सबमिट करें और 2 बजे तक ये लिंक ओपन रहेगा. सभी लोग जल्दी से करेंगे। थैंक यू।
Thank you so much. I am leaving now.